All right. Welcome everyone to the 2022 spring edition of the Cyberbot Educator Workshop. The Cyberbot is, pardon me, I got ahead of myself a little bit. First things, let's go ahead and share this slideshow with all of you because it's going to potentially have some links you may want to follow. So there is the link to this slideshow. And also for anybody watching on in YouTube, because they weren't able to make it today, this link will also be in an email to you and on the YouTube page as well. So you'll be able to get to this slideshow without having to type in this long address. Now, the Cyberbot is a collaboration between Parallax and an organization called cyber.org. So cyber.org is funded by the Department of Homeland Security. They've been around for over 10 years now, but have only recently become cyber.org. They used to be NICERC, NICERC. They've got a staff of 25, and their primary goal is a cyber-ready workforce with an emphasis on cybersecurity, and they produce free curriculum for educators in the US. They're in Bossier City, Louisiana. Parallax is just outside of Sacramento, California. In a city called Rockland, we have about 20 employees, and we've been around since 1988. And we got started in education in 1997, and I'll tell you a little bit more about that. This is Chip Gracie, Parallax's chief inventor, and his brother Ken Gracie, who is our CEO and in charge of marketing. My name is Andy Lindsay, and my emphasis in school was electronics. And when I got here, I started writing textbooks on electronics as an intern and never stopped. It's been 21 years now, going on 22. One of the main emphases that we have at Parallax is the interaction between a microcontroller brain and circuits. Now, those circuits could be in the little display or the buttons that you're using to control something, as in these products up here. Well, the microcontroller inside this, and these brains that I'm referring to are microcontrollers. They're not normally full computers. They're a chip called a microcontroller that's programmed once and then put in an application, at least when it comes to finished products. They're also used a lot in inventions and specialized projects. And so that they have the capability to move, in addition to being that button interface and display interface on your common product, they can move motors, and they can check GPS coordinates and many other things in custom student projects. And so having this programmable brain that goes with circuits makes it so that folks can develop more awesome things in with less effort and less background knowledge than you used to have, say, in the 70s, 80s, or 90s, especially. Chip Gracie, our main inventor guy at Parallax, invented the basic stamp in the mid-90s. And this is the microcontroller that essentially changed its approachability. It used to be an engineer or technician only thing. And the basic stamp, because it was programmable in BASIC, which at the time was the beginner's language of choice, it became very popular. And so one of the things we did was made an educational robot called the Bobot. Okay, so now fast forward 20 years, and there have been a couple of waves of new hobby microcontrollers since then that have taken the maker spaces and inventing with electronics to the next level. And educationally, the current leader is the microbit. And this is not just a microcontroller. It has some other things built into it as well. And for example, with the microbit, we've got, can I get most of you to mute yourselves and then just unmute if you want to jump in with a comment? Okay, so in addition to the microcontroller, which is right here on the back of your microbit, we also have a whole lot of other things you've already experimented.
Andy,
You
you're
muted yourself.
I muted myself. Sorry about that. So did you hear about the 5x5 LED matrix display? No? Okay. So the microbit has, you did hear that it has a built-in microcontroller that's right about there? Okay, good. I'm getting some nods. Thank you. Okay, so in addition to the microcontroller, instead of having to connect everything else to it, like an indicator light or a push button, or something like an accelerometer to sense tilt, what the microbit has is it has a 5x5 LED matrix display, and I'm hoping that many of you got to do the homework before this course, and were able to see messages scrolling across this display. It also has push buttons, a built-in radio, which is amazing. Microbits can talk to each other, and they can also talk to computers over Bluetooth, though not necessarily at the same time. And so in our curricula, we use the ability for microbits to talk to each other as opposed to a direct Bluetooth connection with a computer. It also has a built-in compass, accelerometer. There's just all these amazing extra things that are inside it that make it something that's more of a project core than just simply a processor that you program and connect other circuits to. There you can do that too, because it has this edge connector down here. So that is the microbit. And so what we did was we took the very popular Bobot robot system and set it up so that you could use the microbit on it in many of the same ways. Here's, I forgot to do this during the previous presentation, so I just want to emphasize, if you're looking for if you're looking for Cyberbot products, so this is the Cyberbot right here that has the microbit in it, and that's the name Cyber, of course, came from cyber.org. So this Cyberbot, if you're interested in purchasing Cyberbot related stuff, I put a link here to a page with all things Cyberbot. And as an example, let's see. This is Cyberbot, right? Yes. I was expecting to see the robot that you've got on the first page.
If you go to just Cyberbot, it should be up there.
Oh, here it is.
Mm-hmm.
It's okay.
Yeah.
So the images are changing around a bit, and I think I might have been scrolled down, not sure. Anyway, all right. So here is the Cyberbot robot that you're experimenting with today, and this is the project page. And I'll talk more about educator discounts, which are shown on the project page, when we also talk about curriculum and other educator resources on Friday. Also, I put a page to all things microbit. So if you're now, all things microbit does include the Cyberbot robot, but it should also have some microbit, okay, so here is the microbit V2 club bundle. So that's one of the items that is available. And if you keep scrolling, you'll also find like a microbit Go bundle. Like here's the 1.5 Go bundle. And then here is the 2.0 Go bundle. And I should go back and mention, because there is a 1.5 and a 2.0, that that this slide has the basically shows the differences, which are the version 2 has a touch sensor, a built-in speaker, and a built-in microphone. Where is the mic? Right there. And also a little bit of extra memory for your scripts. So those are the differences. Oh, well, and little notches so that you can, at a glance, differentiate the microbit version 2 from the microbit version 1, which does not have any notches in its edge connector. Additionally, up front, I just wanted you to know that the main Cyberbot tutorials page is linked right here. And it's split up into, you could really think about them as workbooks, and there's quite a few of them. And one of the ones that you already had a little bit of experience with is the microbit only lessons, where you're doing some of the first things in a given activity for just having some hands-on experience with MicroPython. So for example, this is one of the scripts that you got to enter and examine the behavior as on the microbits display. And we'll be visiting quite a few more of these booklets during this workshop. There's quite a lot here, so I won't be able to cover everything. And in fact, the main emphasis is going to be just to make sure that you guys are on a solid footing when you're working with the microbit and the Cyberbot in your classroom. So the agenda for today is going to be an introduction, which we just finished. And next up, we're going to do some questions and answers and a review of the homework you guys did coming up to the course. After that, we're going to calibrate a couple of servo motors before we put the robot together. It's an important step to do before you put it together because it opens up more options as to how you can assemble it. And then we'll do something called adding the cyberbot.py module to our project, which will make the microbit talk with the microcontroller on the robot. Let's see here. And then between today and Wednesday, what we're going to have you do is put the Cyberbot robot together and then add one circuit to the top of the Cyberbot. And we'll go over all this step by step. So it'll be pretty clear and straightforward by the time we get to the end of the workshop. This on the right hand is also a list of some of the things that we'll be covering that has to do with implementation in the classroom, especially. And so adding a library or module is something that we'll be doing today. Centering the servos, that's a calibration process that we're going to do to the servos today. And we're going to find and fix some mistakes in our scripts so that you can see how to do that most effectively. Unmute yourself at any time and ask questions as we go. And on to the homework and review. Okay, so the first thing we did was a quick test to make sure that we had bidirectional communication with the microbit using the software that we'll use to program it. And so let's see here. So we started out, I'm just going to do this really quickly because it goes very fast, and that way everybody who's watching this on YouTube later can see. And my hope is that it will also bring up some questions so that you guys, I'm hoping it'll it'll bring to mind some questions as I go through it. So we started with the USB cable and the microbit. We plugged in the microbit, or plugged in the USB cable to the microbit, both on the microbit end and then on the computer end, so that okay, so I just plugged my microbit into the computer as I was causing it to fall off the table. There we go. All right, now next up, what we did is we went to python.microbit.org. So here is python.microbit.org, and they give you a default script. And what we did after that was we copied in a different script. I guess I'll run this. I'll do that later. Okay, so I'll paste in the new script. So this is a script that what it does is asks you to type a message, and then it displays the message you typed. And what that does is it verifies, one, that we can load a script from this online editor running in a Chrome browser to the microbit. Two, it also demonstrates that that the serial communication, the ability for the microbit to send messages to and from the computer is all in working order. And this was a critical test to make sure that everybody had. So I went ahead and sent you this very early on. And so the instruction said to click connect, select your microbit, and then confirm the connection. And then after that, flash the program. Now, when you're disconnected, notice that it says download. And you can, for example, download the program. And you can also drag and drop that into the microbit instance that will appear in your file browser. So for example, in Finder, the microbit, it might be hard to see, but it's right here. And I could just open my downloads in Finder. And take that microbit program and drag and drop it onto the microbit flash drive instance that appeared when I plugged the microbit in. And then it would load the program that way. That takes longer. It has more steps. And sometimes folks experience challenges dropping it onto their flash drive instance. So we're sticking with the other system that the python.microbit.org editor gives us. You know what, I'm just going to drop it on the desktop. I was looking for the downloads. All right, so what we did instead during the test is we clicked connect, and then that download button became flash. And flash is short for load the script into the microbit's flash memory. Now, after doing that, nothing appears to happen. If we look at the microbit, it hasn't changed. There's nothing being displayed on its matrix LED matrix display. But if you instead hit the open serial button, it doesn't always go perfectly, especially when you're running a Zoom meeting. So I'm going to restart the program by pressing and releasing the microbit's reset button. You can also press and release this Control D to reset button. And then we see that a reboot happened and to type a message. And the main part of the test is that it sent you back that message. So that shows that we can both type in values that this editor will send to the microbit and that it will spit them back to us. And that's going to be most important for the cybersecurity lessons that we'll take a look at on Friday. Okay, any questions? I haven't had a chance to look at the chats. I'm assuming that Stephanie or Ari Alvarez, who are helping out today, would tell me if something came up that they weren't just chatting an answer to, or they felt like it was a question that everybody needed to see.
We have three.
Mm-hmm.
The first question is, what's the difference between flash and download?
Ah, okay. Good question. Okay, so download actually packages this up in a file called, in this case, because the script name is currently microbit program, when we download it, it gets downloaded as microbitprogram.hex, and then that appears in our in Finder. So if we look at the downloads, there is, it might be hard to see, but that's microbitprogram.hex that we just downloaded. So, and then once you've downloaded it, you can simply drop that onto your microbit in the file browser, because the microbit looks like a flash drive to your computer. And that is actually one way to load the program into the microbit, load the script into the microbit. The other way to load the script into the microbit is to click connect, and then you can flash it. Now, when it flashes, it actually takes care of transferring the entire script to the flash memory. So both approaches of download. So if you download it and then drag and drop it onto your microbit as a flash drive, you have transferred the script to the microbit's flash memory. If you click the flash button, it saves you a step, because you don't have to download the hex file, although that's also the way we save files, but I'll get to that in just a minute. Okay, did that cover that question? Looking down at the chats here.
That question was from Nada.
Okay, thank you. Good. All right. And then I also see, how does download differ from save? And the answer to that is actually that they're one and the same. And that brings us to the second part of the homework, or actually this was in the part of the due Monday part of the homework. This was a thing where we looked at, where there were some step-by-step instructions on essentially saving and reopening your script. And instead of watching that on the document, I'll just go ahead and show an example. So first of all, if you want to save your script, give it a name. Now, when you're connected like this, you don't really have the option of downloading your script as a hex file, at least not up front. But so let's change this to serial loop back. A serial loop back is when you send a message to something and it sends the message back, just as this script does. And so once we've named it, actually, I don't like that basic test. Communication. Basic COM test. All right, so here's our basic COM test. And if we want to save that, we can hit the load save button and then select download project hex, which is the same thing that happens if you're not connected and you hit the download button. Either way is the same result. But when you're connected, it's a lot easier to just go into the load save menu and select download project hex. Now, I always use download project hex, or at least there's very few times that I can recall having used download Python script. And the reason for that is because the project hex provides us a better package that can store other stuff. I will get to that in a while.
Yeah, that covers the question, are MicroPython programs .py compiled into .hex files?
Yes, this is a Python script right here, and you can save it as .py, but the .hex is actually packaged to be something that you can both load into this editor and load into the microbit. So it's a more universal thing, and it can also store additional what are called modules. Again, I will get to that in a while.
One more question before I stop bothering you.
Okay, no, please.
This is another good question. Microbit shows syntax errors, which line, etc., but can I view that error code in the online editor?
You guys are getting way ahead of me here. Yes, you absolutely can. Okay, so let's go ahead and make a mistake in our code. Now, first of all, there's two things I want to do with making a mistake in my code. One is, okay, I've got a mistake in my code. And let's just, okay, so how do we find out that that's a mistake? If we flash it to the microbit is going to start displaying its error message. So here it is displaying the error message, but as it scrolls across the LED display, it's awfully hard to read. So as another way to see those error messages, you can hit open serial. And when you do so, if your script has an error in it, the microbit will tell you about it. And it's pretty good at that. It says, hey, in line 3, I don't understand what slep is. Oh, slep. No, I meant to say sleep. There we go. And now it's fixed. And then if we flash it again and open serial, we, of course, won't see the error message anymore. We'll just see the type of message. Okay, how's that?
One last question came up.
Okay.
Is MicroPython, or are MicroPython programs considered interpretive like regular Python programs?
Yes, yeah, it is actually interpreted, and the amount of text you add increases the size of the program too. So there's always a good argument for trying to strike an argument, or trying to strike a balance between verbose and concise as your coding goes.
I think we're caught up for the moment.
Okay, very good. So yeah, it interprets it, it checks each line and then figures out what it needs to do with that line, and then moves on to the next, or jumps to wherever it's being told to jump to. Let's see, what is up next? So that was how to save and reopen a script, which was part of the due Monday homework. Actually, I don't see it in here, but I know I put it in your email, so sorry about that. So we started with communicate, which was in this writing microbit programs lesson. So to get here to this script that we started with, you can start off at learn.parallax.com, find the Cyberbot lessons, writing microbit programs, and then the LED matrix booklet, which is taking a second to load, and scrolling text. Now we also have examples of pre-made images and making your own custom images here. But what I just wanted you to do is if you had not already used the microbit, that you could have a chance to do something like this. And by the way, if you're new to Python, if you feel at all uncomfortable with Python, I just tried to do a Windows trick. That didn't go well. I tried to smack the window up against the side of the screen like I normally do in Windows, but I'm running this presentation on a Mac. So we'll do it like this instead, and then find the other. So what I normally do when learning a new programming language is I go through the tutorials and I set them side by side and actually hand type in the examples. Now, really, before I do that, one of the things I want to do is make sure that I've saved this known working script. So we'll hit load save. and then download project hex. And now we have yet another copy of it in our downloads folder. Okay, now that I've saved it, maybe I want to do this new text. Now we only have an hour and a half, so I'm not going to hand type it, but when I am learning a new programming language, and it's something to encourage your students to do, is to don't do what I'm doing right now, which is copying and pasting the text from here into the editor. That's the best way to not learn a programming language, is to basically copy and paste in and see that it did something and move on. It causes anybody who's trying to learn a programming language to skip across the material too quickly. So typing it helps it sink into your mind in different ways. It helps you think about, what is actually being written and the relationship, and it gives you a better understanding then of the relationship between the code you type and the result. Now, this example script, we start off with the example script, explain how it works. Then we have the student try something. And then we give them a your turn, which is something that does not have a solution in the student tutorials, but it's usually just a small step. And there's also teacher resources where this material is included. So, so not to worry if you don't have the solution in front of you, because it's a challenge for the students, and it's a time for them to learn, because they'll at least have to put their hands on the computer keyboard at this point, if nowhere else. I'm going to change this to print, so that instead of displaying on the microbit's LED matrix, it's going to display in the, oh, I didn't load the, okay, so, pardon me. All right, so first thing to do is we've entered this new script, and the script's name is hello_pi. So we can call this project hello. Save that. Now, if I want to go back to the basic test that we did, I can run to Finder and drag and drop basic com test onto the browser, and lo and behold, the basic com test is back. Another way to do that is to hit load save and select or browse for a file. That should put me in the downloads. And then here's basic com test, open. And then here it is again. I guess I should have, for just another example, opened the other file that I saved, which was hello.hex. So that is how to save and reopen projects. Now, if you want to do save as, you can do something like hello version 2, or simply v2, or whatever name you want to give it. All right, any questions before I move on from there? Okay, so if we flash this and then open the serial, there is the hello message, which otherwise would have appeared on the LED display on the microbit if I'd have left it as display dot scroll. Okay, so quick discussion about the scripts. I'll take each one and paste it in. Does anybody have questions about this? We're importing all the tools from the microbit module, which is kind of a thing that we don't get to look at or edit. It's just available for us. And by the way, you can always hit help and select documentation, and then search for display.scroll. And we'll see lots of examples of where display.scroll is used. And here is a hello world one where it essentially talks about display.scroll and provides an example. The next thing we tried was remembering and using variables. So this.
Couple of quick questions.
Okay.
Does the flash overwrite or add to the code in the microbit is the first question.
The flash overwrites the code in the microbit.
And the second one is the microbit module from Parallax or microbit. This is a BBC microbit.
Yes. So this is the BBC microbit, and it is. Let me get back to my to the slideshow here. This is the microbit symbol at the bottom of each slide, and it actually has an embedded link to microbit.org. The BBC made the microbit in the late 2010s, and they distributed them to over 1 million middle school students in Great Britain. And that's how the microbit got its start. And since it got a rather broad and sweeping start, it has very much become an educational staple. And I'll talk about that shortly. Any more, Stephanie?
Can you retrieve a hex file from the microbit?
No, you cannot retrieve a hex file from the microbit that I know of, although I'm open to corrections on that one. But you can always download your own copy. But yeah, if given a microbit, there might be a way to retrieve it, but I really don't know. That's kind of a deeper subject. But if like I said, if somebody knows the answer to that and it's not no, go ahead and let us know, and I'll look into it and present it later. So here we have a program where it's basically saying, by the way, the pound sign is the way to make a comment. So the microbit ignores this, and you can also add comments elsewhere in your code, although again, it adds to the size of your script in the microbit. So be careful about adding too many comments. But I can essentially go anywhere to the right of something and add a comment by just using the hashtag or pound symbol and saying, this is a comment. All right, so how are we doing on this remember and display stuff? Is everybody okay with saying, hey, we've got a variable, we'll make the variable A 42, which is the answer to the universe in all things. The variable C is the letter M, and the variable D is a floating point value just a little bit above 42. This is an integer value. This is a floating point value. And then display.scroll showed you all those results. So, so that is an example of remembering. So we started with communication. That was scrolling text. Now we have store or remember and use values, or essentially store and retrieve values. Next up is calculating. Can everybody see this okay, or do you need me to put it into, okay, great, excellent. So here we just said we made two integer variables, A and B, and added them together and then displayed the result. Well, we displayed a message saying we're about to tell you what the result of A plus B is, and then we displayed C. So that's a simple example of arithmetic. So that's the calculate category. In the make decisions category, we have if statements. Now, this is not the simplest if statement in the world. As you can see, you can just say only, you can just use if to only do something in response to one circumstance. But you can also say, if one condition's true, do one thing. Otherwise, if another condition's true, do another thing or a different thing.
Here's a question about that code from Debbie Reynolds. why do you need the quotes and the parentheses?
Why
Just-
do we need the quotes? That's a good question.
Just
Yeah,
the way Python is?
It's just the way Python is. No, that is actually covered in great detail. If you go through every single one of the tutorials, you'll know that one inside out, but I'll give you a short answer in just a sec here. So I'm pasting it in. All right, so here we are. These quotes are saying, hey, everything between these quotes is a string of characters. And so we want you to store those as a string so that they can be conveniently displayed using display.scroll or print or whatever you're going to use here. The parentheses is because display.scroll is a piece of reusable code that is expecting a value. It's expecting to receive a value to display and scroll. And you give it that value here. And that value could be simply the number 42. Or it could be a string of text. So that's the difference. That's why we have both opening and closing parentheses. It's because we have to send something. That something doesn't necessarily need to have quotes, but the string inside it, the string of characters, has to be contained between either single or double quotes. This would work too. We've been using double quotes. I'll leave it that way. Oopsie. As long as it's contained between quotes, then the MicroPython interpreter will understand it as a string. Okay, how was that? Was that a sufficient answer? So for example,
I don't see any. There she is. You're still mute, Debbie. You can unmute yourself.
All right. Yes, that explains it. I understand that. Thank you.
Oh, excellent. Thank you, Debbie. All right. Now, this is the first place where we see indentation. So you can do more than one thing. So here is an example of if A is greater than B, we'll display and scroll the number 42 twice for no apparent reason. Okay, back to the original. If we wanted to add something here, like maybe a little time delay, you could say sleep. So that would pause us for a second because sleep is in 1,000 milliseconds. Okay, we are at 1/4 till 2 Pacific time. I want to make sure to not take too long on this. So the main thing I wanted to just mention is, all right, you have this if condition. You have if and then a condition that could either be true or false. If the condition's true, it does what's below and indented from it. And then when it runs into something that's not indented, it moves on. In this case, it's else, which is an extension of the if statement. And you can also have more than one thing indented from that. Now, here's a pop quiz. Right now, these two statements get executed. One, if I set A1, this one will get executed right now because A really is greater than B. Now, if A is not greater than B, like if I made it 1, these two would get executed. Now, what if I added am I going to get what I want out of this regardless of the value of A? I'm seeing some nodding heads.
Some shaking heads.
I'm sorry, some shaking heads, pardon me. And there's good reason for that. And it's because especially in the situation right now where A is not greater than B, well, yeah, it'll display all done there. But if I make A greater than B, it's going to do this, but not anything in here. So a better approach would be to have our final thing at the end of the program saying we're all done, and then that gets displayed regardless of which of the answers ends up getting displayed before that. Does that make sense? Okay, so that's indentation in Python. So indentation is very important in Python. And repetitions is also a place where indentation is important. And it's the same rule. You could have, let's see, what did I just do? Here we go.
I have a question here that I can answer. Will a version 1.5 microbit drive a Cyberbot, or do I need the version 2? They are both fully compatible with the Cyberbot tutorials, and your kit may include one or the other, depending on availability. So
yes,
no worries there. We also have had 2 styles of the Cyberbot board itself, just simply a different method to keep the microbit connected to the Cyberbot board. I believe the ones you all have a slot that slides a microbit into it on top. The previous version, which we still have some inventory, mounts the microbit underneath, and it's held against some spring clips with some little included nuts and screws. And so any combination of those boards and microbit modules are compatible with the Cyberbot. And a question from Robert Argent: can you indent more than once?
That's a really good question. So let's say that, so you guys did this during the homework, and this is one where we simply displayed a counting sequence. Well, let's say that we want to skip the number 5. One thing you could do is you could say if counter is not equal to, did I say equal there? Not equal to 5, and then give it a colon. And then we'll say print not 5. Otherwise, print the counted value. Hopefully this will work.
Okay.
Okay, looks like I did it exactly the opposite. I only printed 5.
Excuse me. Kitty.
Okay, if counter equals 5, we won't print 5. Sorry, having a little trouble putting my hands at the right spot on the keyboard. So here we go. Oops, syntax error. What did I do? It can't even tell what I did wrong.
You need an equals equals.
Oh, that's right.
Good
Okay.
job, Simon. Thank you.
Thank you. Okay, so here we go, where we get our counting sequence, but we have a special situation that the if statement deals with for the value 5. And so that's an example of indenting inside something that's indented. And you can still also have more than one statement in there. And then last but not least, we went to comments, because we always want to make sure that people learn how to document their scripts. And so we talk about, you can make a block comment with 3 quotation marks. And then you can make a line comment, which is everything to the right of the hashtag on the line is just for the coder as a note. All right, without further ado, I want to get you guys to start putting together your Cyberbot. So we're only skipping forward like 50 slides or so, but that's okay. Sorry, what was that, Stephanie?
We're going to center the servos first.
Yes, we're going to center the servos and then essentially go back and talk about informational items with the remaining time. And so centering servos is one of the first steps in putting together your Cyberbot robot. And you'll actually put together the robot as homework between today and Wednesday. Let me give you this link because this link has not been posted. We just came out.
It has been, and I can post it in for you.
Oh, okay. Thank you. I'll race you.
No, you just move along and I'll go ahead and get that there for you.
Okay, so these are the step-by-step instructions, and there's a few things I want to talk about. One is this is the new Rev C Cyberbot board. If we go to the main lessons on learn.parallax.com, here's the Build Your Cyberbot lesson. And the first thing it does is it shows it currently shows the Rev A or B version. And then I think that what we're going to do is incorporate how to tell whether to go for the instructions for your Rev C or your Rev A or B. Is that right, Stephanie?
Well, it shows you which one it's for, and there's a link to the other one if that's not what you have.
Okay.
Because they're both published side by side now.
Okay. So this is the live one here, the Build Your Cyberbot.
Yep.
And, oh, I see. So basically it says it says check.
Mm-hmm.
Okay. So yeah, normally this would be okay.
If you're on the main tutorial page, the Rev C one is right next to the original also. So it's visible on the bookshelf.
Ah, thank you. The main tutorial.
Orange link. Go down to the main lessons.
Oh, okay. Thank you. All right. So
there you go.
So now we're back at that link we just posted to you. Thanks, Stephanie.
You're welcome.
And here is the Cyberbot with a Rev C Cyberbot board. Now, this is what we call the Cyberbot board, and we're going to plug the microbit into it momentarily. Some things about the Cyberbot board: it has a power switch, and then it has what's called a breadboard. That's the white thing right here for plugging circuits into to connect wires and part leads together. It has other sockets around the breadboard for connecting to ground, connecting to the this is not actually the microbit, it's connecting to the microcontroller in the Cyberbot board. And I'll get to that in a while. Then there's also 3.3 and 5 volt sockets up top. Again, a power switch with 3 positions. 0 is all the way off. 1 is everything except for the motor connections that are up here. And then 2 is everything including the motor connections up here. We have a piezo speaker, some direct connections to the microbit down here, some indicator lights on predetermined pins, and lots of other good stuff.
Quick question before people get ready to put this together. Mm-hmm. Do we need to eject the microbit like a USB stick prior to removal?
The reason for that ejection on a flash drive is to protect its data. On the microbit, you can't hurt its data by just disconnecting the USB. So especially your Mac will complain at you if you just unplug your USB. It'll say, well, you should have ejected it. And so it's probably easier to just unplug it and then click OK when it tells you that you should have ejected it instead. Because again, it's not a true flash drive. You won't hurt its data by simply unplugging it. Okay, so what I'd like you all to do is go hunting for the Cyberbot board. And it's going to be in a package. It's going to be in the box that had the Cyberbot stuff. And it'll be in a little silver folder that looks about like that. And go ahead and take it out of the silver anti-static bag. And now it is a best practice to not have power connected to anything when you make electrical connections. So this would be a time to disconnect your microbit from the USB cable. And then what we want to do is we want to plug the edge of the microbit into the edge connector on the Cyberbot board. And you'll have to press pretty firmly. And once you've got it plugged in, what you'll want to see is just kind of a little bit less than half circles on those circular, well, they're nice for grabbing a hold of things with alligator clips. So I consider them to be circular alligator clip spots, but yeah, so these circles should be just a little under half circle when it's plugged in all the way. All right, and then another all points bulletin. This is really important. Please, everybody listen up for this. If you have a metal table, put something under this board because you don't want to have these metal connections, metal electrical connections, potentially touching the top of a metal table. So granite, plastic, wood, etc., no problem. They're all insulators. But if you have a metal table, it could conduct electricity between parts. So put it on top of a piece of paper if you have a metal table. And then go ahead and plug power back in. And we'll also need you to fish out a battery pack and the 2 servo motors. And the 5 batteries that were called out in the get ready for the course homework. So we'll have you grab all these parts. And I'm going to, yes, that's the battery pack. Looking good, Stephanie.
We may have had one recipient receive a Rev B board instead of a Rev C board. I'm doing an individual chat there. If that's an issue for anybody else, I'm going to paste in the directions for connecting the correct page for connecting those in case you accidentally got the Rev B board instead. I'll paste that in the chat. There, that's the alternative. Hopefully it was just one instance of grabbing from the wrong pile.
That.
But as I said, everything else shall work the same for the entirety of the lessons.
I was just looking to see if I have a Rev B board nearby.
I have sent the correct instructions to that person. So
okay. Yeah, with the Rev B board, there's a couple of acorn nuts and screws that you have to attach to the microbit, and then a screw and a nut that you attach to the microbit, and then an acorn nut that you use, a pair of acorn nuts that you use to attach the microbit underneath the cyber bot board. All right. So now that you've got all these parts, so as you can see, I'm kind of showing you instructions redundantly that they're in the workbook. Connecting the servo motors is important. We're going to leave the jumper at 5 volts, although you can set it to VN. This is called a jumper right here. It's a little sleeve that electrically connects 2 of 3 pins. And right now it's connecting the Cyberbot's 5-volt supply to the motors. And we want to leave it that way. And when you plug in the motors, the important thing to do is to make sure that the black cables, well, first of all, you're going to be using the P18 and P19. Those are labels that we can't see through the wires here, but there's a P18 and P19 servo port. And we want the black wires to line up with ground, the red wire to line up with V+, and then the white wires to be closest to the edge of the printed circuit board. So as I plug in the servo, now, okay, that ought to help. So as I plug in the servo, again, you want to have the red, black, white wires with white closest to the edge of the board, black by the GND label, and then just go ahead and plug it over the 3-pin header there. And so here we have now the 2 servos connected. Also plug put the batteries in the battery pack, and then plug the battery pack into, it has a barrel plug that goes in the barrel jack on the board, but first put the batteries in.
So for the order of operations, after you connect the servos, do you then connect the battery pack to power the parallax board?
Yeah, that's a good question. The battery pack is required to power the parallax board. And whether you plug it in before or after, we want to leave the power switch in its 0 position, which is where it comes out of the box. And then that way, when you plug the battery pack in, there won't be any power given to the servos. Okay, how are we doing, everyone? Got it all together? Ready to go? Okay.
What we have a suggestion from Russell. Don't forget to download the modules.
Yes, that's a very important suggestion. And as a matter of fact, I'm waiting for the Zoom menu to get back out of the way so I can get to the. Okay, so there's a check mark right here. So when you're plugging in your servos, we've got instructions to plug in the servos, but it's also saying that if you have not already done so, you should go and add the Cyberbot module to your project. And that's what we're going to do now. And incidentally, I did have a student from an engineering school call with that very problem this last week. So, and they admitted that they were going kind of fast and missed this instruction, and that's why they couldn't get their Cyberbot to work.
By the way, this is being recorded, and the recording will be posted on the page where you found out about this class, and it will also be emailed out to everyone who's enrolled. So if anyone has to leave early or miss a session, we will make sure that you have the recording.
Yeah, we'll send the YouTube link typically between 5:30 and 6:30 p.m. Pacific time. All right, so here is add modules to your microbit. And when you get there, it shows you in step-by-step format how to do it. And it also gives you some animated GIF images that show exactly how to do it. What I'm going to do though, so that the first animated GIF shows how to unzip. And so I'm going to copy the link of that, because we need you all to download the zipped collection of modules. So I just pasted in this link, and if I click this link, what happens is that it opens a new tab, and it takes you to the latest Cyberbot MicroPython zip package of modules. And so I want you all to download that zipped package. And then the next thing that I want you to do is go to your downloads and find that zipped package that you downloaded. And in fact, I can put the download link right in your chat. There you go. So download the zip file and then find it in your file browser, Windows Explorer, Mac Finder, or Chromebook files. And then typically you can just double click the file and it'll automatically unzip it into a folder. Some of you may need to right click the file, and then there should be an option to extract from your zip file. It's going to be really important to have the Cyberbot MicroPython as a folder, not just as the zip file. So make sure that you have unzipped that zip file. How are we doing? Has everybody got their zip file downloaded and unzipped? Thumbs up. Got a few folks still working on it.
You can always unmute and give a shout out if you need something too. I think we're good.
Okay. So the next step here is shown in this animation, and we've got some checklist instructions, and I'm just going to kind of do it in front of you, so to speak. So now that I have it unzipped, that being the modules, what we're going to do is go hunting for the Cyberbot module. And so I'm going to call this script script with Cyberbot module. And we'll put that as the name up here too. All right. So the first step, now that you've got it unzipped, is to go to your python.microbit.org editor and hit the load save button. And then I know you normally use or browse for file to open a file, but in our case, you instead need to hit show files. And when you do, it's going to show you the files in your project. And in order to add a module that has a collection of reusable code that will expand what the microbit can do, we want to hit the add file button. The add file button will open up a file browser in your downloads. And that's the time when you want to find the folder that you unzipped, the Cyberbot MicroPython folder, and open that up, and then select the file that's named cyberbot.py. There it is. And after you select it and click open in the browser, you want to see cyberbot.py down here. Now, after you do that, you can actually change it from microbit import star to from cyberbot import star. So again, load save, show files. If cyberbot isn't here, hit add file, select cyberbot, hit open, and then make sure that then you can see both your main script, whatever it's called, and your cyberbot.py file. If you can see both of those, your project is ready. And I'll go ahead and test this real quick. Flash. Now you have to turn the power switch to 1 on your board for this. I'm just going to test to make sure that okay. So the next test we're going to do is to make sure that with the Cyberbot module and the power set to 1, this script works. This is a script that instead of using from microbit, it uses from Cyberbot import star. And I'll paste it. Yeah.
We have, it seems like I have to add cyberbot.py each time I freshly open up the editor. Workaround maybe to save a blank hex with cyberbot loaded and load that hex on new instances.
Exactly. And that's why I named this one script with Cyberbot module. So once we've tested this script with Cyberbot module, we can save using download project hex the entire thing. Now watch this. If I copy and paste this, okay, so I'll copy just the script and don't do this. I'll reload my own editor. And so we have this, it's going to come up with a default script. Now, if I paste my script that I wrote to test this in, it's not going to work because it no longer has the Cyberbot module. So if we look inside, when I refreshed the browser, I lost the Cyberbot module. However, because I saved the hex file, let's see, where's my file browser finder? There we go. Because I saved that hex file in downloads, there it is. Script with cyberbot module.hex. I know that's really small. Sorry about that. I'll try to get my characters larger in the file browser for next time. I just dragged and dropped from, I dragged the script that I saved that had the module added into the browser. And now when we go to load save, voila, we have cyberbot.py back again. So yes, anytime, it's best to save a blank cyberbot script and then open that as your starting point for any project that involves the cyberbot, because the hex file, the cyberbot.py module travels with the hex file. It will not travel with a Python script. It only travels with the full hex file that gets transferred to the microbit. But since that's a thing that we can open and edit and then give a different name and save again, we're good. So I pasted this script into your chat window. And what I want you to do is paste it over whatever you've got in your Cyberbot or in your MicroBit MicroPython editor window, and then hit connect, and then flash your microbit, and make sure that your 3-position switch is in position 1. Then go to open serial. And what you're looking for is the I'm alive message. Microbit not connecting. Let's see here. Mark, do you have a Rev C board? Okay, I want to go over this one more time. So we downloaded and unzipped the Cyberbot MicroPython folder. We want to have load save, and then check show files, and make sure that you can see cyberbot.py in there. Also on your setup, you want to have this 3-position switch here. You want to have that set to position 1. You want to see 1 light on. Your battery pack needs to be plugged all the way into the barrel jack on the Cyberbot board. You want to have your USB connected physically to your computer. Okay, if we've got all that hardware set, then coming over to the software, we want to be connected. And we want to check and load save to make sure that you can see both your main script, main.py, and the cyberbot.py module. Still no message, huh?
Getting lots of no message reports.
Yeah. All right, let's see.
Are you getting? Is it working for you?
Flash. Open serial. wait for 2 seconds, and then it shows I'm alive.
Okay.
I'll redo this to do it on the display, just in case we're having a hiccup with the, okay, display dot
Mark
print.
Peters is saying, I think I had to select paired.
Okay, okay, so that would be, I just flashed some
Oh,
bad.
got it now. Batteries were not in, right? Misspelled display, various things for various people. Okay, good. We were sweating there for a moment. Okay. Someone had forgotten.
I need to jump in. I guess I'm just being slow here. I did exactly what you said step by step, but when I do the load save, I see those 2 files.
Oh, good, good.
When I X out of that, there's nothing on my screen, on my microbit on the computer. There's nothing.
Okay, so go to the chat. I'm going to paste in a slightly expanded version. I just need to test it right real quick.
So are we supposed to see something on the microbit or on whenever we click on the serial saying alive?
Well, the main thing is you need to have this script running. So a module is just some tools that your script can use. And I just pasted in what hopefully is a working script. I forgot to test it. So now it's going to display both on the, yeah, it'll display on the LED display and in the terminal. And so copy that from your chat and then paste it into, is the chat visible when I drag it out in front like that, or is it hidden by Zoom from everyone?
I'm not seeing it.
Okay. Okay. Yeah. So basically find the script I just pasted into the chat and shade and copy it, and then go to the script in your editor and shade whatever you've got there, and then paste in this script with microbit module. Then connect, flash, and you can either open serial or it'll display and check for I'm alive, or it will display on the LED display as well. You could also try pressing and releasing the little button underneath the microbit right next to the USB cable. So if you press and release this button right here, it'll restart the program. Okay, so how are you doing now? Does it look like has everybody got, how are we doing now? How many no workies do we have?
I'm still trying to troubleshoot.
Okay, where are you at?
I copied and pasted your code in. I went and added the Pi script. I've saved it, reloaded it, tried to connect. I flashed it and connected to the serial, and I wasn't getting anything.
3-position switch in 1 as opposed to 0?
I'm in position 2 right now, or position 1, excuse me.
Oh,
Yep.
okay. Yeah. 1 or 2 is fine, although 1 is preferable for this.
Okay.
Okay. So the next thing to do would be to check to make sure that the microbit is firmly inserted into the socket. You could
That it is, because before I had loaded the Pi script, I was getting the error. So I did get a display coming back.
Okay. Okay.
Doesn't
Getting
help.
it.
I left my glasses at work either.
Oh, yeah. If you're farsighted, that makes it tough.
We are
Hmm.
getting a bunch of thumbs ups in the windows, so we are having some people getting this to work. What might be, given that it's 2:26, do you think maybe you could show running the servo centering and
Yeah, and then we'll
just
get
the
you troubleshot
process,
afterwards, David.
and then we'll
Okay.
do one-on-one with those who are stuck, and that way we've had a chance to show everyone before they may have to leave.
Yeah, and actually, you know, as many of you as can stay, let's make sure to stay and get our servos centered. So that is okay. So I'm going to do them both at once. So I'm going to modify this script slightly. This is the center servo script from the tutorial. And we'll put that now. Oh, everybody, please make sure to save, to give your script a name that you can recognize so that it has the Cyberbot module, and hit load save and download project hex, because we'll need to open that to work with on Wednesday. Okay. And so what I want you all to do is see, first of all, I'll go ahead and adjust this so that it centers both servos at once. So this is the script that I'm going to paste you in just a minute. I want you to all watch what I'm doing though. So I'm telling both servos to stay still by giving it a speed of 0. And you can go to plus or minus 200 for each speed, but we want to start with 0 because 0 isn't quite going to make the servos stay still. So what we're going to do is find the screwdriver in our kit and adjust the servos. So I'll flash this. And then I have to set the 3-position switch to position 2 to give the servos power. Okay. So here we are in position 2, and hopefully you can see that the servos are turning slowly. So what we need to do to make the servos stay still is there's a little hole in the servo right by where the 3-wire cable goes into its case. And Stephanie, does this look okay? Can you see?
Yep.
Okay, so I'm going to put the Phillips end of the screwdriver into that hole and into the Phillips slot. And then I'm going to turn it one direction, and lo and behold, the servo starts turning faster. Well, I don't want that. I want it to stop. So I'll turn it the other direction instead. And it slows down. Oh, I went too far, and now it's going the other way. So I'll switch directions again. And then I'll kind of go back and forth until I find, and you got to use a really light touch until you find that sweet spot where it stays still. And then you're done with that servo centering, and you can move to the next servo. And it's the same process. Okay, so once you've got both servos centered, you'll be ready for tomorrow. And now I will paste you the code.
Thank you.
Copy. Now remember, this code needs to be run with the switch in position 2. There's the script.
Oh, we got a thumbs up and we've got a fun. That's good.
And let's call this one center servos. I think that's what I'm a little off of the workbook script, but not too far.
Yeah, the workbook just has you center one and then change the one line to address the other servo as a way to reinforce the fact that the pin argument is what's directing the signal to use the right IO pin.
Yeah, because if you look above the servo cables where you have them plugged into the Cyberbot board, you'll see that one of the servo ports has the label 18 and the other has the label 19.
More thumbs up.
All right, so I'm going to add one more. I'll give you one more script because we'll use this to put, no, we'll just do, well, what the heck?
We're already at 2:31 and we have some folks that were waiting for one-on-one.
Okay. All right. So let's just briefly talk about your homework and then move on to questions and answers. So for your homework,
So many thumbs up.
what we're going to do is have you put together your Cyberbot robot. Now that you have the servos centered, you'll have a choice of whether to center mount the servos. That's with the little output shafts that you're going to put the wheels on. They can go closer to the middle of the chassis. And that's preferred by, at least that was the original design intent of Parallax. It's more like the Roomba. We think it looks kind of cool. The challenge is that if you want to recenter it, you have to usually pop out the battery pack, which is undo 2 screws, remove the battery pack, and then you can get the screwdriver into that hole. A jeweler's screwdriver also works. So some classrooms choose to instead mount the wheel, the shafts that you're going to put the wheels on closer to the front. Now that does make centering easier because you can actually easily approach from the front with a screwdriver to recenter it. But and additionally on sudden stops, it never does a kind of a backward wheelie. The tail wheel jumps a little bit, but the maneuvering does tend to be a little clunkier. And also sometimes the wheels slip when it's trying to turn because it's at a torque disadvantage. So I recommend mounting the servos in the center. Now, with that said, going back to the instructions that you're going to be following, and I'll email you these. There's a build the chassis page, and it's going to show you, okay, get all these parts, especially the wrench. You'll need that. And then it'll show you, okay, grab just these parts from it and put it together like this, along with a text explanation of the same thing. And so you're going to go through and unscrew the servo horns, and you'll just follow along with these instructions going from one page to the next. And it's going to show you how to do everything. And once you've got those things done, you can keep on going to the next page. And I listed all of these pages in the homework that I'll send out. And one thing about the battery pack, definitely make sure to use the white nylon screws when you're attaching the battery pack. Right there and there. Don't use metal screws for that. Then you'll put the wheels on. And then last but not least, you'll attach the Cyberbot board, reconnect the servos and the power, and it'll look about like that. And then if you want to use some sort of strap to get your servo cables all nice and neat underneath, that's fine. I prefer to wait until I prefer to just kind of twist them up and tuck them under between one of these servos and the chassis. You can see the metal chassis underneath. And then we can neaten this up after Wednesday, because you may end up having to be concerned with which servo is going into which port. And it's easier to follow without doing that. So skip that step. And then we'll talk about the communication between the microbit and the Cyberbot board on Wednesday. So that's all. That's we'll build the whisker circuit on Wednesday. We'll not build it. I was going to have you guys build it today, but I didn't quite go fast enough. So sorry about that. We'll build it on Wednesday, which is actually normally when we do our first sensor circuit. So on Wednesday, we'll do some navigation, and then we'll build and test a bump into objects sensor circuit. And let's see here. Wrong list. We'll also have questions and answers. We'll talk about navigation and how code corresponds with navigation. we'll build and test a touch navigation circuit. And then we'll talk about some of the other circuits that you can build, and we'll have you build one of those for Friday. All right, so that's it. Now let's move on to questions, answers, and tech support.